This last question, we're going to use Fleury's algorithm in context. We've got a floor plan of one floor of Euler's Museum. The floor plan shows the rooms and doorways that join them. The openings in the walls are the doorways, and we'll refer to each room with that single letter as indicated. And so Euler designed the floor so that each visitor can walk around this floor, passing through every doorway without using any doorway more than once, as long as you begin and end correctly. So, follow the steps to see how this is possible using graph theory. So first of all, we're going to draw a graph to represent the floor plan. So we'll draw the graph right here. So we're going to put P out inside here, and P looks like it connects with B, and I'll scoot down just a little bit. P also looks like it connects with C, and then B only connects to T, and T looks like that connects over here to R. R goes back to C. Looks like we've got an M and an S. And make sure we get those drawn up correctly. So they both connect to C. And M and S connect to each other. And then let's double check all this. So P only has two doors, so that goes there. B only has two doors, so T and P. T only has two doors, so here and here. R has two doors, to T and C. S has two doors to M and C. M has two doors, and C has four doors. And if you listen to what I said, those doors were the indices for each vertex. So notice we said 2, 2, 2, 2, 2, 2, and 4. That means they're all even. That means there is an Euler circuit. So not only is there an Euler path, but it is an Euler circuit that goes through there. And since they are even, we can, in this case, start anywhere we want. So this is the simple case, and just to back up, it's going to look messy, but I'll show you what I'm referring to. Back to Euler's theorem. If all vertices are even, the graph has at least one Euler circuit, which is also a path, and every circuit and every Euler circuit can start at any vertex. So it's going to work. This is the easy case. So remember, the only ways that we had an Euler circuit or an Euler path was if they're all even, or if we have exactly two odd. Anything else, it's not going to work. So, back to this guy here, and I think down at the bottom is a place for me to write the sequence, so I'm going to scoot that up actually. There we go. So all we got to do is figure out where we want to start. So I will draw this in a different color just to make it look nice. Draw it in this blue, or maybe our little green, maybe that'll look better. So I'm going to start at P. I'm going to start at P, and I'm going to go over to B. So there's P is where I started, then to B, then to T, then to R, then to C, then up to S, over to M, back down to C, and back to P. So there is our Euler circuit that completely covered every doorway. We hit a couple of rooms. So we hit room C. I guess that's the only one we hit twice. We hit room C twice, and then P twice, once on the way in and once on the way out. But we didn't touch any edges more than once. In fact, we touched them all exactly once, and that's what makes an Euler path.